Listen, every maintenance pro out there knows that absolutely gut-wrenching feeling. You know the one. The alarms go off, production just completely grinds to a halt, and the clock immediately starts ticking on your facility's profitability. It's stressful, right? But it turns out the silent and honestly most expensive culprit behind all that unplanned downtime isn't some mechanical flaw or a bad part. Today's explainer is all about defeating a silent saboteur that is sitting right inside your compressed air lines: water.
Okay, let's dive right into this. We've got a really clear roadmap for today's explainer. 1. The hidden cost of moisture. 2. The physics of condensation. 3. Equipment and quality at risk. 4. A layered moisture defense. And 5. Choosing your treatment system.
Section 1. The hidden cost of moisture. The silent saboteur of uptime.
We really need to stop looking at moisture as just some simple nuisance or a minor byproduct you can ignore. It is way more dangerous than that. I mean, unplanned downtime costs manufacturers thousands of dollars per minute. Thousands! And the reason this matters so much is that the physical presence of liquefied water inside your system, it doesn't just sit there. It's actively launching a slow-motion attack on your operational efficiency. It causes corrosion, it creates pipe scale that actually breaks loose, travels right through your system and blocks your air passageways. And what does that lead to? Massive, system-wide pressure drops and severely degraded machine performance across your entire facility. This damage is wide-ranging and it's completely cumulative.
Section 2. The physics of condensation. Why water gets into your lines.
Now, what's really interesting about this is we have to understand the relentless physics at play here. Specifically, a thermodynamic process called adiabatic compression. See, all atmospheric air carries water vapor, always. When a compressor draws in that ambient air to pressurize it, the temperature inside rises sharply. And this hotter air, it can suddenly hold significantly more water vapor, which means your compressed air becomes heavily saturated. The real trouble kicks in when that pressurized air leaves the compressor and cools back down to your standard ambient facility temperature. Because as it cools, its capacity to hold that moisture completely drops. And all that water vapor condenses right out of the airstream. It literally turns into liquid right inside your lines. To put that into perspective, this number completely blew my mind. 30 gallons. Just think about that volume for a second. If you have a standard 100 horsepower compressor operating on a typical summer day, say 86 degrees Fahrenheit with 80% relative humidity, and you're compressing that air to 100 psi, that single system is going to generate roughly 30 gallons of liquid condensate in just one 8-hour shift. 30 gallons. And again, this isn't a leak. There's nothing broken. That is just your system working exactly as physics dictates. Section 3. Equipment and quality at risk. The slow-motion attack on your facility. So where do those 30 gallons actually go? Well, when that water hits your pneumatic cylinders, it literally washes away the pre-lubricants. That leads directly to corrosion and sluggish response times. When it reaches your solenoid valves, it eats away at the rubber seals, causing ruptures and leaks. Honestly, even trace amounts of moisture can cause your sensitive sensors to completely malfunction. And your air-powered tools? They start sticking, they jam up, and their performance just tanks. Water is systematically destroying your vital machine components, one by one. But here's the thing. The damage doesn't even stop at the machinery. It extends to the end product itself. Moisture actively ruins products across so many different industries. If you're in spray pointing, it causes color and finish degradation. Doing industrial inkjet printing? Say goodbye to good adhesion. Blow molding? It destroys your material consistency. And in highly regulated spaces like pharmaceuticals and food processing, water in those airlines completely compromises compound integrity. It can even lead to microbial growth, which is a massive safety hazard. So moisture isn't just a maintenance headache, it is a full-blown threat to your quality control. Section 4. A layered moisture defense. Building your treatment strategy. Okay, now that we've thoroughly agitated the problem, it's time to actually solve it. Because we are fighting relentless physics here, we need a military-style strategy. The most effective compressed air treatment strategies recognize one very simple truth. No single device can eliminate all moisture at once. There's just no magic bullet. We need a 3-stage layered defense, with each stage targeting a very specific form of water. Step 1 attacks the bulk moisture. Step 2 hunts down the droplets. And Step 3 acts as your final passive defense. Let's break these down. So the crucial point is that compressed air exiting a compressor can hit 300 degrees Fahrenheit. That is way too hot for industrial use, and it is absolutely loaded with moisture. Step 1 is installing an aftercooler downstream. This rapidly drops the temperature to a workable range. And here's the best part. That cooling alone releases 70 to 80% of the excess water vapor as liquid condensate, which you then just discharge via automatic drains. Boom! That's a massive 75% chunk of the problem solved right out of the gate. But your air still remains saturated. You've got about 25% of the moisture left, meaning we absolutely need more protection downstream. And that brings us to step 2, water separators. These devices mechanically yank liquid droplets right out of the moving airstream. They use centrifugal force or resin filter elements to do this. For instance, if you look at technologies like SMC's AFF Series water separator and filter, they can achieve up to a 99% water removal rate for droplets and solid particulates. Their specific design prevents the filter element from getting saturated too early, pulling out those droplets so they simply never reach your tools. Next up is step 3, the drip leg. Honestly, a drip leg is incredibly simple but so effective. It's basically just a vertical pipe section installed at each airdrop line. By grading a larger cross-sectional area, it passively slows down the airflow velocity right before the air reaches the tool. Because they have more momentum, the heavier water droplets just fall downward and collect at the bottom of the leg to be drained away. It's your highly cost-effective, passive final line of defense against any stray liquid that somehow survived your upstream treatments. Section 5. Choosing your treatment system. Matching solutions to requirements. This is the point where facility managers need to audit their floors and select the exact right system for their specific operations and ambient conditions. And this brilliantly illustrates a vital distinction you have to make when you do that audit. Water separators address liquid water. They mechanically remove droplets using physical force or filters, but they do not fix water vapor. If your facility needs to remove invisible water vapor to guarantee that condensation doesn't just reform later down the line, you have to reduce the dew point of the air. And to do that, you need an air dryer, either refrigerated or desiccant. It's pretty simple. Separators are for liquid, dryers are for vapor. Now, while aftercoolers and drip legs form a really fantastic solid baseline for most general industrial environments, some operations just demand more. If you're working in pharmaceuticals, food processing, electronics, or precision manufacturing, you have highly sensitive, low dew point requirements. You absolutely must add downstream refrigerated or desiccant air dryers to your layered defense to get the air sufficiently dry. For these operations, the baseline just isn't going to cut it. There's a quote from our sources that just hits the nail on the head. It says, "Moisture in compressed air isn't an anomaly, it's physics. The only question is whether you control it or let it control your uptime. It's an unavoidable physical reality, but it absolutely demands an active, engineered response from you and your team. Because getting this right, it isn't just about maintenance, it is a critical production reliability and product quality decision." So I'm going to leave you with this final kind of provocative question. Is your current air treatment system actually fighting the physics, or is it just hiding the symptoms? It's really time to find out. I highly urge you to audit your own facility's compressed air lines today. Look for those pressure drops, double-check those solenoid valves, and really consider consulting with experts, like the team at Automation Distribution, to size and build a comprehensive sequence of aftercoolers, separators, and dryers that actually matches your specific operating conditions. Seriously, don't let 30 gallons of water dictate your uptime. Thanks so much for joining me on this explainer, and I'll catch you on the next one.